Alright, so if for whatever reason you weren't here for the last class, again, if for whatever reason you weren't here for the last class, I want to quickly show you what we went over during the last class. Alright, so as always, as with the previous class and all my classes, you go out to the P drive for the class, there's the homework, this is the in class. So this is what we did last time. We literally built 3 Java programs as a class. That's kind of a misnomer, which means that really we built the employee program and then we copied it and made some minor changes on it. All right. The stuff that you're going to see, especially in Chapter 2, where we use that the scanner and the employee 2, where we use the scanner, and employee 3, where we use the input dialog, etc. That's all in Chapter 2. All right. So you're going to see that stuff again today. In fact, they take almost the same program that we built as a class the other day, almost that same program, and they build it in here. All right. So, but theirs is GUI. So we're gonna take a look at it. Again, I found a few things for some Eclipse, some cheat sheets, and as John said, there's a bunch of stuff online too. Again, Eclipse is the editor that we're using. All right. So that stuff's out there. Again, if you weren't here for the last class, not PowerPoint, the YouTube presentations, the lectures, both lectures are out there on the system. All right. And I'm currently taping this one. All right. And I found out that although I can't get to, it's telling me that I can't get to PowerPoint because there's a conflict with some kind of weird conflict with the security software, but I'm overriding it by going out and bringing up the PowerPoint from the virtual desktop. So, all right. So Chapter 1 that's in your book, I'm going to go over, and literally, you'll be hopefully pleasantly surprised at how short this takes. Because I don't want to tell you why program, hardware, software, etc. I want to concentrate on the Java stuff and on here on object-oriented programming from this chapter. So if you time me, it's about 5 after 10. I'm hoping that by no later than quarter after, we're done with this. All right? All right, yes. No, that's what I'm saying. If somebody finds one, you want to share it, that'd be cool too. All right. The problem is most of the stuff that's out there, if you find a PDF, technically you've got an illegal PDF, so I can't share them with you, but you could always find it and share it with everybody else. All right. Gaddis, who is the author of both books that I'm using for the classes, has got a very easy, I think at least, a very easy type of style, and the books are very similar in the way that they're set up. So again, it's not my intention. If you want to know hardware and software, take a class with Denny Wright or Inda Conway, etc. All right, you can find out a lot more than I could give you. I understand this stuff, all right, but I have no desire to sit and talk about it right now. That's why we're buzzing through this very quickly. Just so you know too, because people have asked me this, you can run Java. So if you're in this class and you have a Mac, you can run Java on Mac. All right, I believe you can load Eclipse for the Mac. I don't know why you couldn't. All right. So what's a program? What's an algorithm? Let's just start right here. This is the same chart that's in your book on, I don't know what page. I guess it's around page 7. All right. And I'm not going to go through any of these other than to show you just this one, Java. It's an object-oriented programming language. It was originally created by Sun Microsystems, who spun it off and sold it to Oracle. So Oracle not only owns the Oracle database, but they also own Java now and all the rights, etc. to it. I'm not going to go through the history. One thing that's kind of interesting about it, just so you know, and I'll just mention this, is originally it was called Oak, because James Gosling, who was one of the creators of the language, outside of his window where he worked, there was a huge oak tree. He was thinking of a name, and wow, that was pretty cool. But then they found out there already was a language called Oak. And it's evidently, from the way the story goes, they were sitting around having a cup of Java when they were thinking about it. All right? That's it. That's all the history you get from me, okay? All right. If you look in your book and you go up to page 10, and I'm not sure if it's in these slides or not, but on page 10, in the bottom third, they've got the Java keywords. There are somewhere between 40 and 50, just taking a look, something like that. All right, I guess probably between 50 and 60. But those are words that have a specific meaning to Java. In other words, you can't use those. There are some words that Java purposely put in there with the idea that they will never be used by anyone. For instance, if you look in there and they're alphabetized, goto. There is no goto in Java. But Java wanted to make sure you couldn't use it. So they made it a keyword. All right. This is very similar to the type of program that we did the other day. All right, so if you weren't here. But I just want to run through these major components one more time. First of all, if this, bless you, if this is called payroll, you must save the file then, bless you, as payroll.java. And it is case dependent. You couldn't have a little p here and a big P here or vice versa. All right? So this, and every java.java file has to have a public class in it. It can have 0 or more private classes, but only one public class. And that class, again, has to be the name of the file. And the caseness has to be the same. What you'll notice is much of the stuff in Java, in fact, if you look again on page 10, every keyword is lowercase. So the public and the class have to all be lowercase. Have to be. All right? Java is what's called a block structured language. So everything you do in Java, you put between curly braces. Okay? So our whole program starts here on line 1, ends on line 11. Okay? And then inside of there, what we'll be doing for the first few chapters is we'll always have what's called a main in our program. All right, main is kind of the origin. It's the starting point. It's not a keyword. All right, but what this means is what public means right here. For now, just look at it as like a public figure rather, where everybody has access to it. For now, just think of it that way. We'll get into it more depth in a later chapter. All right. Class means that literally we're creating a class called payroll.java. All right. And static here means, for right now at least, that means there will be only one main. There can only be one main. That's just the way that it's set up. You're going to see that, and that's the way it is in all Java programs. If you write a Java application that's got 500 different files in it, there'll be only one file that has a main in it, because that's the starting point for your program. All right. So the difference between this and this, other than the obvious differences in the names and stuff that you can see, is that's the class, that's a method. Main is the name of a method. When you write functions inside of object-oriented programming languages, they're typically referred to as methods. All right. So not only is the class public, but this main here is also public. There's only one main, and it doesn't return anything. If it doesn't return anything, you have to put the word void in there. So it's void of a return type. So this is called, these two things here, public and static, are known as access modifiers. That's the return type. That's the name of the method. And in the parentheses, those are the arguments that the method requires. So main requires a string array, that's the bracket, and it's called args. We will virtually never use that, so you don't have to worry about it, but you have to write it in there anyway because the system expects it. All right. Then on lines 5 and 6, we're creating 2 variables. Actually, I'm sorry, 3 variables. I don't like the way the author does this here. I like it better if you say double gross pay, semicolon, then on the next line, double pay rate equals 25.0. I'd like them on separate lines, please. All right. But there's two different types of variables here. Int, which means whole number only, and double, which means that it can potentially have a decimal place. And I want to show you something that they discuss in the book, but it's later on, and they just gloss over it. And it might sound simple, but I just want to make sure, for lack of better words, you've heard it. Okay? I'm going to come up here, and I don't think it lets me, yeah, this is just some kind of a screenshot, so it doesn't let me grab the code, so I'll have to type a little bit of it in. But if I come in here, and I type in this, so I like they've got here, so where they've got this, double gross pay, comma, pay rate equals 25.0, what I'm telling you is I want you to write that as double gross pay, and for now we will initialize all of our variables. All right, you can say 0 or you can say 0.0, it really doesn't matter, and double pay rate, oops, equals 0.0. But what I want to mention to you is there's another type that you can use in Java that also allows you, if you want to, it allows you to use decimals, and that is float. But if I had done this, so I'm just going to grab this one and copy it. I want to show you why most people don't use floats. All right? So you can see all the stuff right here. If I'd made these floats, and if I typed it in, if I typed it in like this and like this, it wouldn't work. Because by default, if I don't put anything extra at the end here, it thinks it's a double, and I've said it's a float. So if I want these to be floats, I have to manually put in either a lowercase f or an uppercase f. And most people don't like doing that, so they make things double. Even though double gives you that much, you know, really a lot of room, where float gives you about that much. All right, so I don't care if you use float, all right, but if you do, you're going to have to put an upper or a lowercase, and it doesn't matter which one you use. You can even mix them. One could be upper and one could be lower. So again, I also think it's a good idea that when you're doing this stuff, that you put a comment off to the side, you know. So maybe I would have reversed these and done the pay rate first. Oops. All right, I think they also had in here what? It was int hours or something like that. Again, I would come over here, and I don't care if you line this stuff up or not. That cannot have, if I try doing this, 0.0, that won't work. Because you can't have a decimal place in an int. Int is whole number, so I have to do this. But I'd like it if you'd put comments over here, even if you're using good variable names, which I want you to use too. So hours worked, hourly rate, and then basically it would be what? Hours times pay rate. And you'll also notice when you look here how the author is using what's called camel casing. I want you to use that too. So gross pay, these are variables. For variables, the first, if you run words together like this, the first word is all in lowercase. Then as you add other words to it, the first letter is capitalized. Again, that's referred to as camel casing. That's kind of the standard as far as how that's done. So I'll expect you to do that. All right, so what we're telling it here is what? We've got 3 variables, 2 of which we've initialized. So multiply the 2 we've initialized and put the result in our other variable and then print it out. Now, hopefully that's pretty obvious what's going on here. This literally should say your gross pay is $1000.0. That's what you get if you run this. And don't worry about it, the $ and the point 0 as opposed to 0.00. That's all in later chapters. All right, we'll learn how to do that. It's just some simple formatting. Okay. The other thing that's in here that the only thing I haven't discussed is this. System.out is, you might have guessed, there's a system.out and there's a system.in. By default, system.in is your keyboard by default. Sometimes you don't want that. If you're getting information from a file, you can make system.in a file. System.out by convention, all right, is your monitor. But you can again change that. So you might want to write that out to a file or someplace else. All right. But what this is saying is there is a built-in Java class out there someplace, and in there something is defined called system. Okay. System dot out means we're going to output it. Dot println means print it, and when you get done printing it, move the cursor down to the next line. If instead of saying system.out.println, we said system.out.print, it would print your gross pay as 1000.0, and your cursor would be right at the end of the line. Get the difference? So print keeps it on the line it's on, print line puts it on the next line. Okay? So, and they explain what, again, the same stuff that I just gave you. I don't want to read PowerPoints to you. This is a language, just like with C#, you do have to put semicolons at the end of virtually every line. Okay. So he explained what happens in memory when you say int hours equal 40, that someplace in memory, if you look at memory as being a bunch of mailboxes, all right, that it's putting the equivalent of 72 in there. It's kind of what's happening. All right. They talk here about something that's called the virtual machine, and I'm mentioning this because you'll hear it. It's called the JVM, typically, the Java Virtual Machine. Java is different than most programming languages for a lot of reasons, but one reason is most programming languages, what they do, if your programming language is both interpreted then compiled, a programming language will be interpreted first, then it'll be compiled. Java compiles first, then it interprets. So when you run your program, you don't see this happening, but when you run your program, so that payroll program, when you run the payroll program, if it works, it creates a file called payroll.class. That's the file that it actually compiles then and runs. All right? All that stuff is done and handled by the JVM or the Java Virtual Machine for you. All right? Microsoft has got something similar that happens, and we'll talk about it at another time in C#. Again, Java files must have a .java extension. If you want to know more about compilers, they talk a little bit about them in here. All right? Errors. There's 3 types of errors that you're going to make, and we all make them. The first are actually, they're the easiest type. They're syntax errors. All right? What you'll find in here is, unlike what you just saw, those of you who were in the last class, unlike Visual Studio, where if you forget to put a semicolon at the end of the line, all right, you get some of that stuff with Eclipse, but it's probably not, it's a little more cryptic. Some of the error messages that you get from Eclipse as opposed to Visual Studio. But syntax errors are errors in the language. So you put this in there. Oh, yeah, that one. And you put system.out.println instead of printline. That's a syntax error. The stuff has to be in this caseness. If you don't do that, it's a syntax error. Usually those are the easiest ones to find. All right. Then there's what's called a runtime error. So for instance, if we were going to do some kind of thing where we asked the user to enter 2 numbers, then we divided the first number by the second, and we gave them the result. If you put in 0 for the second number, all right, you're going to get a runtime error because that's a divide by 0 exception. Okay? Those you can't find out typically until you actually go and run the program. And then the other kind, they're the worst because they're logic errors. And we all think we're infallible and never make errors, but we all do. You mean to add 2 numbers together, but you multiply them instead, or something like that. That's why you test the heck out of programs. So it shows you here, and this picture is someplace, I don't really care, I guess it's on page 13 in your book. Okay, it shows you what's happening in here. Okay. They go through the different Java additions. That's interesting reading if you want to. Okay. Compiling, this isn't the way we do it. You can actually compile Java programs from the command line. If you're really that interested in it, talk to me and I'll show you how to do it. It's not that it's hard, but you don't. If you do that, you don't need Eclipse. Okay. All right. And they go through how you do that. Then they talk about IDEs, things like Eclipse. All right. That's basically, that's the kind that we have. I think that is a picture of Eclipse right there. All right. They go through the programming process. Then, and again, you may have heard me say this already because it's not that different from what we talked about last semester in the Java or JavaScript class. But if you look on pages 18, 19, and 20 in your book, they talk about object-oriented programming. Let's just keep it simple. What you're doing when you're writing an object-oriented program is you're modeling. You are. And I may have even given you this example last semester. But if you imagine if they decided that in downtown Janesville they were going to build some kind of an arena to do something, they wouldn't just, start pouring concrete and do it. They'd have to get everybody to okay it, etc. And somebody would build a model of it to show what it was going to look like. All right? Why? Because it's much easier to pick apart a model than it is to go and create it and then say, you know what, you made those bathrooms too small. All right? You don't want to do it after the fact. So what you're doing with an object-oriented programming is you're modeling real life. Years ago, and they still do some of it, but years ago when companies were doing any kind of testing, cancer testing or whatever, any kind of testing like that, they always used live animals. And for, they used typically rats and stuff like that. And some of that's still done. But places like PETA really complain. So a lot of that kind of testing right now is done through simulation. They simulate a human digestive system with code. All right? That's done using object-oriented programming. All right? You're modeling something that actually exists out there. So they talk about that in here. And they talk about what object-oriented program is, what objects are, etc. And I've talked about some of this in other classes before. and they get into data hiding. We do this every day. I don't know about you, but I mean, I know when to get my oil change, etc. I know some things with a car, but other things I'm not very good at. I don't really know exactly what's happening when I take my car out of the driveway and I put it in reverse and start backing up. And I don't need to know. I just know what gear to put it in, and that's all I need to know. The rest is hidden or abstracted from me. So they'll talk a lot about abstraction, and that's what they're talking about. The idea with object-oriented, one of the reasons it's been around for a long time. The first object-oriented programming language was called Simula 65. Guess what? This year that language turns 50. So people who say object-oriented is brand new, no, it's not. It's gone where it's been popular, not popular, popular, not popular, now it's popular again. This is one of the big things. Reusability. That's a bad word for you as programmers. Because a lot of times with reusability, what that means is they'll hire less people because they can reuse a lot of the stuff. So they go through what a class is and what an object is. I'm just not going to do that. If you have a desire, you can read through it yourself. What you can also do, and we might get into this by the end of the semester, but it'll be more next semester, is inheritance. Inheritance in some ways, again, is like genetic inheritance. But again, I've given this example before. If you've got man A who mates with woman B, and they both have a big nose, there's a pretty good chance that the child will have a big nose. It doesn't always happen, but usually it does. All right? Well, it's not like the child can sit there and take off that nose and put on a different one. That's what you can do with inheritance. All right? You inherit something from a parent, but if you want to change it, you can change it. All right? So then they go through the whole process here of what is designing, what is writing, testing, debugging, etc. That's it. All right? Well, it took a lot longer than I thought. But that's it. So let's look at the second chapter here, or at least start to get into it. We'll go for a while, and we'll take a break. So you can see what they go through here. I'm not going to read any of this to you. You can look at it. A couple things I'll mention. Primitive data types. There's 8 of them in Java. We'll go through them in just a minute. That means there's simple data types. All right. They're also known as atomic data types. They're in their final form, so to speak. All right. More stuff that we'll talk about in here. And also, I don't know if you like this or not, but there's a lot of this in there. Well, we'll get to it. Where you'll see an arrow coming up on the screen, etc. And that, so this is an animated PowerPoint. All right, it's not mine, it's Gaddis's. So we went through this already. This is similar to what we looked at before, but instead of doing this, he has no variables in here whatsoever, just the print statement that comes out. Programming is great fun. Then he breaks it down. Don't worry again about that compiling. And notice this is what I mean. All right, so he says, I love that. That's a blank line. Okay, I guess I couldn't have figured that out myself. But he goes through and he does explain in here what everything is. All right. So you may like that, you may not like that. All right. But I would rather go and explain it to you and use my words than use his. All right. Special characters, as they say right there. There are 3 kinds of comments that you can write in Java. We may have looked at this last time. I really don't remember. But again, for those of you who weren't here, that's a single line comment. So if you put in 2 slashes, everything to the right of it is a comment. This is a multi-line comment. So it starts with a /*, ends with a //. Be real leery, because the one we didn't talk about last time starts with a /*. That's what's called a Java doc comment, okay? And it ends with a /*, or // rather. So that one is a Java doc comment. And people usually ask, well, that's fine. Okay, I see what you're saying, but I've never heard of Java doc before, all right? So I'll come right back to this. So if you're copying it down, I'll come right back to this. But just so you see this, if I go out to the site for Java, and you can get there different ways. I always just do java.sun.com, which is the old way, but it pushes you over to oracle.com. If I go out there, and I'm just going to grab something from here, so I'm going to go out and find Java APIs, and I'm going to grab one of the newest ones, Java SE8, and I'm going to come over here, and I'm going to look down here for one that you'd probably be able to recognize and probably understand how it works. and that is I'll go down to string. Okay? So if I go down to string and I start looking at some of the stuff that's in here, okay, what's going to happen is if I look in this, and they changed this a lot since I looked at it. Oh, here we go. All right. The stuff that you see that's in here, where it's got fields, modifier, etc., all that stuff was written using Java comments. So it'll write some it's external. It'll write some external documentation for you. All right. And if you say, do we need to worry about it? No, I don't require you to put any Java comments in. You're more than welcome to do it, but you don't have to. All right. Anytime you use an if statement or a while loop or a for loop or a do while loop, which we'll be getting into, that condition must go in parentheses. Also, you saw it in the header, where it said the main stuff. After main, what was in that string, bracket, bracket, args, that was in parentheses. All right. So they're used more than just in the method header. They're used all over the place. I mentioned that Java is a block-structured language. Everything goes within curly braces. All right. Luke asked the question last hour about double quotes. Same kind of thing in here. Strings go in double quotes, not single quotes. All right. And all lines that are going to be executed must end with a semicolon in this language. All right. Don't worry about the console window and all this other stuff. Again, we're using an IDE. This assumes that you're not using an IDE. Okay? All right. They explain, the difference. I just mentioned it to you that if you say this system.out.print followed by system.out.print followed by system.out.print, since only one is a print line, they'll be all printed on the same line. All right. To me, that's a waste of time to keep going over this. If you want to force a new line, so system.out.print, you put \n. This is worth mentioning because the two characters that you will use most often in here will be \n, which is a new line, and \t, which is a tab. There are other ones, but those are the ones you're going to use virtually 100% of the time. All right, the other ones that are in there probably aren't nearly as important. So I guess, well, there you go. There are the other ones. There used to be one in here, and I don't know if it's still set up or not. There was a \a, which would ring the bell on the computer. All right, most people found that irritating, so they turned it off. Okay. All right, so they give you some system.out examples, etc. What's a variable? We talked about this last semester. This is a great definition. He should have just stopped right there. A variable is a named storage location. Since it's a variable, it can vary. What we'll get to in a couple minutes is what's called a constant, which can't vary. All right. A literal is what goes basically on the right-hand side of the equal sign. So if I say var hours equal 40, int hours equal 40, hours is the name of the variable, 40 is the literal that I'm putting into the variable hours. Okay? Same type of thing. He runs through this. Again, this was driving me nuts going through this morning. All right. So he shows you a program with a variable in it. Now notice he's got this on two different lines, int value and then value equal 5. You can put it on two different lines, or you can put it all on the same line. So you can say int value equal 5. Sometimes you'll create a variable and you don't know what the value is. You might want to ask the user a question and base the answer on that or something like that. All right. And the thing is, if I were with this line that we have right here, the system.out.print line value, this one, if I put that right here, everybody understand what I just said? If I said int value semicolon, and then on the next line I said system.out.print line value, what would happen? Program would blow up. I would get what's called a null pointer exception, which means that right now the value of this variable is null, which means it's unknown because we haven't set it yet. So if I attempt to use it before I've set it, I get a null pointer exception. All right. And I'm only telling you that because it'll probably happen to everybody in here at one time or another. It still happens to me. Notice here it says the plus sign. You can use it for two different things. Addition, like we all know, and right here, if you look at that first example, really any of these examples, that's concatenation. When you can use an operator like the plus sign in two different ways, it's known as the actual name of it is it's an overloaded operator. All right, so an overloaded operator can be used in more than one way. The system knows how to use it, which way to use it based on context. If right here, if we had said system.out.println and I put inside of the parentheses, if I put another set of parentheses, if I put 6 plus 9, then it would print out 15. But the way this is right here, it would print out hello world. Yeah, and they go through that. The best way to learn this is to just sit and play with it. All right? Make a lot more sense once we start doing that. All right, what's an identifier? It's basically anything in a program you create. So the syntactic rules for classes and variables and methods are the same. The syntactic rules. The only thing is, again, you already saw that with classes, they start with a capital letter all the time. Methods and variables typically start with a lowercase letter. Okay? And then you use camel casing after that. You can't have a class or a variable or a method that's the same name as one of those keywords that you saw, the 50 to 60 keywords on page 10. What's weird is, so I can't create a variable, for example, called goto because it's a reserved word. But I can create a variable called goto with a capital G if I want to. So you can get around it that way. It's recommended to always start your variables with lowercase letters. All right, and your methods. So here's the other rules. The only thing you can put in there are upper or lowercase letters, digits, underscores, or the $sign. I will recommend that you never use the $sign in any variable name in this language. And notice the underscore. What that means is, show it on the next page? No. That sometimes what you're going to see, depending on whose book or whatever you read, sometimes you'll see a variable that'll say like this, double tax rate, which is the way I want you to do it, equals 0.0. Sometimes they'll do it like this, double tax underscore rate equals 0.0. Either one of those work. This is considered the older way of doing it. This is considered the newer way of doing it. And that's the way I'd appreciate it if you do it that way. If it really bugs the heck out of you, and you say, I know I got to do it this way. I don't know why, but if you have to, then you're going to do it that way anyway. All right. All right. They go through the same thing here again. Variable names start with lowercase, classes, uppercase, okay? And really variable names and method names should be like this. All right. Okay, here's your 8 primitive data types. Not that you have to memorize this. The key thing in Java to realize, and I'm going to say a word to you that you'll hear next semester, but now it doesn't have to mean a thing to you. All right? And that word is pointer. Java does not support pointers directly. What that means is if you pass any of these, anything that's of type byte, short, int, long, float, double, boolean, or char, any of those, you always pass a copy. So if you pass it from one method to another method, and that method changes it, you're changing a copy. You're not changing the real thing. How do you get around that? That's in later chapters. There are ways around it. Okay? So again, these are the 8 primitive or atomic data types. Byte, that's an integer, but it only has a range by default of negative 128 to positive 127. Okay? Short, I think, has got negative 32,768 to positive 32,767. And int is negative 4 billion something to positive 4 billion something. A long is a number I couldn't pronounce because I don't know when you get up that high. All right, bless you. Floats and doubles, remember these are both ones that can. So all of the ones that you see here on the left, all of these, those are all integer. They're all whole number only. Float and double can have decimals. The difference between them is float allows you to have more precision both on the left and the right of the decimal point. Boolean is true, false only, and char is when you use that single quote for a single character. And that's not even true. Just so you know, and again, I'm just telling you this stuff as I think about it. To Java, that's a single character. All right. What the backslash is doing, it's called an escape character. It's turning off the special meaning. If you didn't have it there, it would think it's an N. But by putting that in there, now it says, oh, it's new line. All right, so it looks at that as being one character. So I could create a character variable and assign that to it inside of single quotes. That would work. Here's your different ranges. I guess I would have been better off looking there. All right. And what they have here, int, I don't think that's right. I thought it was 4 billion, but maybe it is too. Okay. They're big honking numbers. That's 2,147,483,648. All right. And these I can't even read to you. Because when you start, 10 to the 38th, or 10 to the negative 308th. That said, notice this is the key thing here. Floats 7 digits of accuracy on the right of a decimal point. And you might say, well, what big deal? Seven digits? That might be the difference between hitting the moon and missing it for NASA. So they'd be using doubles. All right. And then they show how you create variables. Variable type followed by the variable name. And again, you can initialize it at that time. Java variables, Java is a quirky language, and you'll learn this as we get into it. Java variables, sometimes, depending on where you put them, sometimes they are initialized, sometimes they aren't. In some places, they're automatically initialized, and in some places, they're never initialized. All right, if that wasn't enough to screw with your head a little bit, you'll see that when we get into it. All of these right there, if we declare them at the very top of the program, before main, but at the very top, this would automatically be initialized to 0, to 0, to 0, to 0, to 0.0, and 0.0. If I put them inside of any method, like main or whatever, they'd all be, right now, they would all hold null. All right? And you'll see that again as we go on. So they talk about what an int is, what a floating point. So if you want more of that, again, you can go take a look at what's in there. You can work with scientific notation, which is sometimes easier for people to read and work with. All right, boolean I already mentioned are true and false. Char I already mentioned, again, inside of single quotes. And I already said that. That is one character to the system. That is not the number 1. That is the character 1. That has no arithmetic value whatsoever. And I always tell people when that confuses them, it's like in a string. 6004 South County Road G, that's the address of this place. There is absolutely no arithmetic value in 6004. There isn't. You can also work with Unicode characters. If you haven't ever heard the shtick on this from me or somebody else, we used to have just the ASCII character set where there are only 256 characters. You can still go and Google ASCII character set and it'll show you all of them. And there's a lot of things that aren't on your keyboard, like the division sign with a minus with a dot above it and below it and some other good stuff. But when you start talking about other languages, all right, you get into Unicode, and with this is actually old because as far as I know, the new Unicode standard supports over 100,000 different characters. It's not 65,536 anymore. All right. If the stuff we looked at before, so int hours equal 40. That's how I'd read it. That's how we all read it. But technically, to the compiler, it's take 40 and use that to assign the value of the number 40 to the variable hours. So single equals means assignment. Double equals means check for equality, and we'll get to that in a later chapter. All right, so here's some examples. Again, I'd rather have that on 2 different lines. You should be able to look at that, though, and understand what that means. There's not a lot of rocket science in that particular program, in all seriousness. All right. Variables can only hold one value at a time. As it says, local ones are null. They don't receive a value. They must have a valid type. Well, that's hopefully, again, that just makes sense, but you can't do this. I can't say double tax rate equals because I'm trying to stick a string inside of a double. So it won't work. In the same way, I can't create a string variable and say string name equals 34. That won't work either. What I could do if I wanted to is I could put this in there, and then it would actually, the program would think my name is 34. But that's legal. But the first way was illegal. You can, yes, tell me if this is what you're asking. I can come in here and I can say double tax rate equals 0.07, and I can say double another tax rate equals tax rate. Like that you can do, sure. If you want to do that, then you have to declare this one before this one. There are languages you can flip that and it'll still work. This is not one of them. In many ways, this is a really, really, really literal language. And you kind of look at it this way, that you know, you've got big brother, big sister, whatever you want to say, watching you, and as long as you follow all the rules, you can do almost whatever you want. But when you start breaking rules, no, you're going to be in trouble right away. Here's your operators. You've seen these before. You saw those in JavaScript. All right, plus, minus, asterisk for multiplication, forward slash, don't use a backward slash, forward slash for division, percent sign for modulus, which is the remainder operator. Then they explain what all those are. And integer division, again, this sometimes confuses people. Hopefully it won't. But if I do this, int num1 equals 17, int num2 equals 2, double answer equals num1 divided by num2. Can somebody tell me what's that answer? Yeah. What do you think answer holds? All right. You would think it holds this, but you'd be wrong. It actually holds this, because when you divide an integer by an integer, since it's happening on the right-hand side of an equal sign, it says to truncate the result. So how do you get around that? I'll show you 3 ways of getting around it. Just grab the same one here, put it in here 3 times. You do what's called casting. So I can cast like this, or I can cast like this, or if I'm really a glutton, I can cast on both of them. And notice, I'm never changing any values, because it's on the right-hand side of the equal sign. The only time you're changing something and making a change to it, I'm making a copy right there. So what this one does is this changes that 17 to 17.0. This changes that 2 to 2.0. And this changes both of them. Does that make sense? So in all 3 of these cases, now it will be 8.5. All right, which is what you'd want to have. All right, they start to go through the operator precedence. We're going to be adding to this. The bottom line is this. If you're in doubt, use parentheses. I've been told by people I over-parenthesize, but if it makes sense to me, I don't care if you think I over-parenthesize. I will tell you that the more parentheses you put in there, it may take longer for the program. You know, I've seen people literally, I don't know why you do this, but I had a student years ago who did this just to show me they could. For like something like this, let's just keep this one in here. They literally did this. They said, you know, that works? Yeah, it does. But what the system has to do is it has to do this first, then it has to go and do what's on this set of parentheses, then work its way out, and all it's going to do is complicate it and make it take longer. All right? But sometimes you do need them, because again, if I come in here and do something like this, let me get rid of some of this stuff here. So if I say int x equal 3, int y equals 7, int z equal 10, and we'll set int a equal to, for right now, 0. And if I say, for example, a equals x plus y divided by z, well, the way this works is you do that first. You always, it's like high school math. So you're going to take y, which is 7, and you're going to divide it by z, which is 10, but since it's an int divided by an int, it throws that away, and it's 0. So you're going to take 3 and then add it to 0. Well, that's not what I wanted. I wanted to get 1. Then you have to put in, now if I do this, now it's going to add 3 and 7, which gives me 10, divide it by 10 and give me 1. So again, when in doubt, parenthesize. I tend to even do this. Again, that's overkill, I get it, but I'm leaving no doubt. Java has a built-in math class. All right, do you have to care about this? I'm wondering, I thought that M in there had to be capitalized. I think that's a mistake in his book, but I could be wrong. And the key thing about this is you can just call these. They're available to you at any time. So if I want to do a square root, for example, all right, I could just call math.square root. We'll get into these in a later chapter, okay? All right, the combined operators, I'll show you these real quick. And again, we may have looked at this in JavaScript. I really don't remember anymore. But let's just do this. I'm going to get rid of all these. All right. If I want to come in here and say something like this, x equals x plus 7. Okay, that's totally legit. X would now have a value of 10. That should make sense to everybody. But what I can do instead of this is I can say x plus equals 7. And let's say I'm going to assign that. Let's say what I'm going to do here is I want to take a and assign it to x plus 7. All right, that's a really bad example. You can do this, but I can also cut it down to x plus equals. You can do plus equals, you can do minus equals, all the mathematic operators. And what I should have done is just stick with a book because I'm sure they gave you an example in here someplace. There you go. So x plus equal 5 is the same as x equal x plus 5, etc. Okay? Do you have to use those? No. But again, they are built into the language. This will break down into the zeros and ones the computer understands faster than that will. They've done studies on it. They wouldn't have created it otherwise. It wouldn't have made sense to do that. Java is strongly typed, so if you say something's an int, you must put a whole number in it. All right? You can't, right here it says this will cause an error. Why? Because we're trying to take the value of a double and assign it to an int. You already know how to fix that. If you went and put int, if you said right here, int or x equals parentheses int parentheses y, that would take the number 2 and assign it to x by casting. Okay. This is how they rank. So under these 6 different types that hold numbers, double has got the highest rank. What that means is if you've got an expression that combines doubles and floats and longs and ints and shorts and bytes, on the right-hand side of the equal sign, the compiler will take all those variables and convert them all into doubles. And it does that for you. So that's not what you told us before. If you write it the right way, that's what will happen. And they'll show you some examples of this when you do conversions. I'll let you look at that. There's the cast that I already mentioned to you. All right, they give you some cast examples, maybe better than the one I showed you. I don't know. When you do different types of things, it's known as mixed. So if you combine a byte and a short, all right, it says it converts both of them to int because technically they're 2 different data types. Right? So when in doubt, you want to try to make everything the same type of data. All right, when you can. You can't always do that. You saw in that, that program that they showed, I believe the reason, the one at the beginning where he had the hours and he had the pay rate, the reason I think he made hours an int was to show you that you can combine different types. All right. But probably, because a person can oftentimes work part of an hour, rather than making hours an int, you probably would have made that a double. All right, and then they should give you some rules with all this stuff too, and you can take a look at this. The final, just so you know, so if I'm writing my program and I type in this, so if I've got int x equal 3, later on in my program, so ... means somewhere else, I can say x equals 23. Not C. X equals 23. Totally legit. No problem with that. But if I say this, if I say final int x equal 3 and I try to do this later, I get an error message because it's a constant. All right. Java follows most other languages that usually your constants are in uppercase. You don't have to do that, but usually you do that. Send a subliminal or some other kind of message to the user, hey, what we're doing here is a constant. Yes? No, the capital letter doesn't mean anything. It's the final that matters. And final has other meanings. We just haven't gotten there yet. So some people do it like this, too. They use the underscores. Again, it's a matter of trying to come up with and coming up with a convention. All right. Java, again, allows you to work with strings. And this, what I'm going to say right now may not sound like it makes a heck of a lot of sense, but I just want you to hear the terminology. And that is this. If I come in here and write this, string, name equals Jeff. All right, and again, where I put the dot, 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 that just means that someplace in here I'm going to write more code. So there's some more code in here someplace. And then later, I can make dots. Later, I come in here and I say name equals Jeffrey. All right, as an example. What I want you to realize is strings are what are known as being immutable. What that means is when I do this, someplace in memory, someplace, I don't know where, but someplace in memory, it goes and it puts JEFF in there, or the machine language equivalent of JEFF. When I do this, it doesn't use the same memory location. It's guaranteed that it will change. What does that mean? That means that you've got a memory location that isn't being used anymore. It might still hold JEFF, but it's not being used by the program anymore. So what Java has is something that's called the garbage collector. It's not like my garbage collector where my wife or I bring out the garbage every Monday night for Tuesday. Garbage collector runs from the operating system when it's got a spare millisecond or two. And it's kind of like, and you may have heard me say this in other classes, I don't know if I mentioned this before or not, bless you, but it's kind of like a meter maid, where if you know what a meter maid is, where the meter maid comes and puts a chalk mark under your car and then comes back an hour later, and if that chalk mark's still there, you might be hosed. Well, it does it the same way. What it does is if it sees this, and if that memory that holds JEFF isn't being used anymore, it flags it. Then when it comes around again, it checks, and if it's still flagged that it hasn't been used, then it gets rid of it. Now, what you can actually do in Java is you can do this. That attempts to call the garbage collector. But since the garbage collector really isn't under your control, it's under the control of the operating system. If I miss my garbage on Tuesday, I can stand out there on Wednesday and start screaming for the garbage man or woman, but they're not going to come. All right? But you can do that. Sometimes you see that in programs. That's why I thought I'd just mention it to you. All right, I'm going to buzz through the rest of these, and then we're going to take a break. All right, primitives I've already mentioned to you. All right, if it's not a primitive, typically it's going to be a class type variable. We don't get into that for quite a while yet. There's how you create a string. That's how I do it. You can also do it like this. And if you say, why would you do it, instead of doing it like this, why would you do it like this? Because that's all other objects, all other non-primitives, that's how you're going to create them. You're going to use the word new. Okay, we'll see that as we go on. Scope is where something is known. I already started to talk to you about that. All right, I said that if you create a variable at the top of your program, right under where it said public class employee, right underneath that curly brace, all right, then the scope of that variable is the whole program. You don't have to pass it. You don't have to do anything special. You can just use it. If you create a variable inside a main, it's known only in main, unless you pass it to another routine. We'll get into all that. I mentioned the kind of comments in Java. All right. They'll probably have a much better Java doc comment than I showed you. Maybe they won't. Was that it? Yeah. They don't show what it, there it is. That's what they look like. That's what I wanted to show you. Much better than the example I showed you. Right. Programming style, I want you to develop your own style. For instance, real simply, some people when they write this, when they write an if statement, they write if x equal 3. And they want the curly brace to be there. You know, y equals 7. And then they put the thing there. I don't do that. I put mine curlies on their own line. That's style. Just develop your own style. Just be consistent with it. I can figure out your style. But I can almost guarantee you that if you, well, sometimes I'm going to do it like this and sometimes like this, and then I thought of another way, you're going to be screwing with your own head. I can figure it out. So can the compiler. You may have a problem with it. You know, the compiler is very literal. It always does whatever you tell it to do. So they go through different ways of creating stuff in here. And then, I'm not going to talk about this, because we talked about this last time. This is that keyboard input. That's that scanner that we added. So if you weren't here, you'll want to go back and read this. This is all the way up to, just so you know, this is all the way up to page 90-something in your book. So this starts on page 89 in your book. And they talk about using the scanner class and how you have to import it. We did this the other day. And then it shows you the different things that you use in here. The next line, next byte, etc. And that's actually shown much better in your book on page 91. They explain each one of these. All right. And we did that last time. So we wrote a program that looked like this. And then we went and looked at dialog boxes. And I said that's as GUI as you're going to get this semester. We looked at the J option pane. That's what you have to basically import that particular Java package. And there's the input one. I'm sorry, there's the input one. There's the output one. We did that last time. So again, if you weren't here, just take a look at it and read it in the book. We're going to be using it over and over and over again. If you want to force a Java program to end, this is the line you use. System.exit and then the number 0 in parens. 0 means normal program termination. All right. We're just about finished. See why I hate doing PowerPoints. They never end. All right. What we'll get to in, this is chapter 8. These are what are known in here as wrapper classes. Notice, for example, double.parseDouble. That D is a capital, and so is that one. When we did this in JavaScript, we used parseDouble and parseInt. They work very similarly in here, not identical. We'll get to that later. And they show you an example of using it if you want to see that now. All right, you can also use what's called printf. Now you'll want to read this. I'm not going to go over it now, and you might decide, you know what, I don't want to use that. It seems like a lot more work than I have to do, and it is. But the reason I'm telling you this, and the printf, it's in your book on 104, 105, 106, 107, maybe a few more pages. That's how you do it in the C programming language. So if you want your stuff to look just like C, you can start doing it like this. It's not totally identical to C, but it's very close. All right. And some people, yeah, well, I might just as soon learn it once and do it that way. So anytime you use system.out.print or print line, you can use printf. But you don't have to if you don't want to. And they show you some examples of using it. And the format specifiers and the field width and all that pretty nice stuff. That's all semantic stuff. All right, that's it. So let's take a break. Sorry, it's a little longer. It's 11 o'clock. So let's come back at 11:15 and we'll pick it up there. I think we're going to write another program as a class then. All right? And Andrew and Nick, Stefan's here, so if you guys have got a minute to come over here.